Solving right triangles. To solve a right triangle means to find the measure of the three sides and the measures of the two acute angles. Consider this triangle. The red box indicates the right angle. Can you identify the parts of the triangle with regards to its side? The yellow side, which is opposite to your right angle, is what we call the hypotenuse. And the blue side and green side are the other two legs of your right triangle. Thus, any right triangle can be solved provided we are given the length of any two of the three sides, or the length of any one side and the measures of one angle, other than the right angle or any of acute angles. Remember your 6 trigonometric functions? If theta is an acute angle of a right triangle, then we have sine theta is equal to the length of the opposite side over length of the hypotenuse. Second, we have cosine theta. Length equals length of the side adjacent over length of the hypotenuse. Third, we have tangent theta equals the length of opposite side over length of adjacent side. The 6 definitions can be remembered easily using the acronym SOH-CAH-TOA. S for sine theta, O for your opposite, and H for your hypotenuse. C, cosine theta, A for adjacent, H for hypotenuse. Your TOA, T for tangent theta, O, opposite, and your A, adjacent. Thus, the other three can be obtained using the corresponding reciprocal identities, acronym SOH-CAH-TOA. C for cosecant theta equals H hypotenuse over O your opposite. S secant theta equals H hypotenuse over A your adjacent. And your CAH, C for cotangent theta equals A adjacent over O your opposite. Recall also the definition of Pythagorean theorem. The square of the hypotenuse, or the longest side of the right triangle, is equal to the sum of the squares of the two legs. Or, we have c squared equals a squared plus b squared. And you also know that the sum of the angles of any right triangle is equal to 180 degrees. Now, let's try to identify what is the opposite, the adjacent of an angle in standard position. For example, in this triangle, the theta in standard position is here. The side opposite to it is your opposite side, and the side opposite to your right angle is your hypotenuse. So the sine of this angle is equal to the length of the opposite side over the length of your hypotenuse. In this slide, the adjacent of this angle is the orange line, and always remember that the hypotenuse is the opposite side of your right angle, which is colored blue. Thus, cosine theta is equal to adjacent over hypotenuse. Now, if we use tangent theta equals opposite over adjacent, or your TOA, the opposite side of your theta is the opposite side which is colored blue, and the adjacent side of your theta is colored orange. What if we consider now the other acute angle as the standard position of the theta? So our theta now is right here. The opposite of the sine theta is the opposite side, colored orange, and the hypotenuse is colored blue. For cosine theta, its adjacent is colored orange and the hypotenuse is colored blue. For the opposite of the tangent theta, we have the side colored orange and its adjacent is colored blue. Don't confuse the adjacent with the hypotenuse. For the hypotenuse is always the opposite side of the right angle. Let's try this example. Solve the right triangle shown at the right here if y is equal to 8 and h is equal to 10. Since the hypotenuse h and the other leg y are given, we can use the Pythagorean theorem to solve for the other leg. So we have this s squared plus y squared equals h squared. So we can substitute the given value. So we have x is equal to square root of h squared minus y squared equals your h is 10 and your y is 8. Therefore, your x now or your unknown is 6. Since we already have the length of the sides of the triangles, we can use the cosine theta function, cosine function, to find the angle. So we have cosine theta is equal to x over h, since our x is your adjacent and your h is your hypotenuse. So your x is 6, h is 10. Therefore, our theta or our angle is 53.13 degrees. Take note, we also have another angle, your delta. So to find the delta, we can subtract it directly. We know that the two angles are equal to 90 degrees. So 90 degrees minus your 53.13 degrees, which we get earlier, is equal to 36.87 degrees. So that is now the value for your delta. Another thing to remember in your right triangle is your angle elevation and angle of depression. The concept of angle of elevation and angle of depression is often encountered in most applications of the right triangle. The angle of elevation or depression is the acute angle whose vertex is determined by the line of sight and the horizontal line. So this is line of sight and your horizontal line. The term angle of elevation denotes the angle from the horizontal line upward to the line of sight, while the angle of depression denotes the angle from the horizontal line downward to the object or to the line of sight. We can do now the applications of the right triangle. Example, the angle of elevation from from a point 75 feet from the base of the tree is 40 degrees. How high is the tree? So first, we should illustrate the given problem to make it easier. So we have here our tree, our angle, which is 40 degrees, and from its angle to the base of the tree is 75 feet. So the question is, how high is the tree? Height of the tree is opposite to your angle or your given angle. And this is your adjacent. So given your theta is 40 degrees, adjacent 75 feet. So we should find the height of the tree or the opposite side. So solution, we can use tangent theta since it is opposite over your adjacent. Substitute the given values. We have our theta 40 degrees. Opposite is our unknown. Adjacent is 75 feet. So tangent 40 degrees is equal to 0.8391. Multiply by 75. We can get now our opposite side, which is 62.9 or 63. So therefore, the height of the tree is 63 feet high. Now, it's your turn. From the top of a building 48 feet from the ground, the angle of depression to a car on the ground is 35 degrees. How far is the car from the building? To answer this one, just write it in the comment box. Okay, that's all. Don't forget to like and subscribe our channel. Bye!